one. So let's talk about number 10, torque, okay? So we just learned torque, right? So torque is defined as Fr sine theta, where R here is the D we use in our lectures, but the same thing. So you have force, which is where the force is acting, and then you have a distance from the acting point of the force to the rotational axis, and then you have angle theta, which is the direction of these two. I mean, the angle between the two. And when the torque makes the system go counterclockwise, it's positive, otherwise it's negative, okay? In this specific setup, officially we want to put a meter stick here and then put some pivot point at the middle. And then if you choose this as your rotational axis, there are going to be two torques given by these two mass here, okay? And then they need to balance each other, but everything's balanced. When this thing is balanced horizontally, so you have two torques, they'll just balance each other like that, okay? And in this lab, I want to do it at home. So basically, what you need is choose something like a meter stick, okay, to balance it, and put something underneath it, okay? If you don't have a meter stick, choose something. You can use like a board, a wooden board, or whatever you have, like a very long book or something, you know, very. As far as you have a rod or a very thin, like a board or something, you know, very narrow board or a rod or something, you can use it as a meter stick. And then just choose two objects, not necessarily the weights like we're showing here, but two objects, put them on the two sides of your meter stick. And so what you want to do is you want to, first of all, balance the meter stick or whatever you have, okay, by itself. So this thing itself is staying horizontal. And then put the two weights on both sides and balance them, okay? And then measure the mass of these two weights using a kitchen scale or a bathroom scale. Make sure you have the units in kilogram, and then measure the distance, okay? Using a tape measure or a ruler or something. And basically, I'll let you do just 4 trials. So in each one, you have 2 masses measured, and then you have 2 distance measured, okay? And then based on our formula here, you can calculate tau 1 and tau 2. And then you can only put the absolute values here, because when you calculate them, you won't get the minus sign anyway. So the idea is the whole thing can be balanced. The sum of these two, one of them being negative, is going to be 0. So that means the absolute values you got here should be really close to each other. Very close. So you can calculate the percent difference of these two torques in the last column. Okay. So I want to do 4 trials, meaning that you can put these 2 objects on there and then change the position of them so that they can be balanced again. And you can choose another object, 2 objects to do the same. Okay. So I didn't write it here, but I want you to attach a picture of the setup you have for this lab, okay? Because this is a at-home lab, so I want you guys show your picture, what kind of objects you used in doing this lab, okay? But this lab is pretty simple. It's just like basically practicing what we learned from chapter 8 about the basic concept of torque, okay? And I think it's fun to do, not only because it's simple, but also you should get really good accuracy for this lab as well. Because this is like essentially there's no velocity, nothing's moving. So you should be able to get pretty good accurate result, okay? Do you have any questions about this lab? We're good? Okay. Yeah, I think these 2 labs are both simple and also fun to do. So I think if there's no more questions, we're done for today, okay?